All right, so I'm recording now. Okay, that's great. Great, you can hear me. Okay, so I was asking before now, right, about your progress. And okay, you said you've watched half of it, right? That's the teaching on introduction to Python, right? It's using Kaggle. And in order not to, compress a lot of information on you at the moment, we'll just touch on machine learning, right, today, and then please make sure that you can find time to go through the cargo, right? Because that will help for the assignment I'm about to give, the project work I'm about to give for the cargo. So at the end of the day, we're able to build a project. I dropped the link in the chat box, right, for cargo. And before we are done with this meeting today, I will take my time to go over it with you. So in case you have any questions at any point, please don't fail to let me know, right? Okay. Yeah, in case you have any questions, please don't fail to let me know in the chat box, right? All right, so moving on. Yeah, moving on. So let's touch on machine learning, right? And I am aware that if you've been in a class before, right, where we've spoken about machine learning as well. Let me know in the chat box if you were present in that class. I think Mr. Eugene spoke about machine learning, and I was there as well for the class. So um, I am very sure that he took that class on machine learning. But I'm just going to give a brief on it today because of what I'll be, like the project I'll be giving to you afterwards. So like I said, if you have any question at any point in time, I'll be on the lookout for the chats, right? So I'll be on the lookout for the chats. You just let me know. All right, Bo. I believe we know what machine learning is right now because so far we've been able to, learn a lot. Um, And I believe that you've been able to pick one or two things from the class so far, if not anything, at least the definition of machine learning. So machine learning is a subset of AI, right, of artificial intelligence. Remember that our class, this course is basically on AI. So machine learning is a very, very important aspect of AI. And you see that most times they are paired together, like AI and machine learning, they are being paired together. And what is machine learning in the first place? We all know what is AI, and I believe I also saw your project and your activity on AI and the research you did, and I'm very sure that we all have a very good understanding of AI. But then when it comes to machine learning, what is machine learning so that we do not confuse both of them, right? So machine learning is simply a subset of AI, right? It enables computers to learn and make decisions without being explicitly programmed. What does this mean? The ability for a machine to learn the activities of human and be able to perform it, right? By learning, they're able to perform it. They're able to learn and then carry out several activities that a human carries, right? And you see that at the end of the day, humans are still like the backbone of AI and machine learning because without us, without the data and the patterns that we feed to this machine learning, right? Start feeding it these algorithms, there's nothing for the machine to learn from, right? So machine learning is a very, very key aspect of AI, like I said before. And some key concepts in machine learning before I get down into the types of machine learning that we have on the screen include data, algorithm, training, testing, and prediction. So I'll be using these words as we go by. And let me just give you an overview. I'll also send this to the chat as well so that we can also go through it in our own time. So what is data? We've all been hearing data, data, data when it comes to AI and machine learning. Um, Machine learning relies on data, right? And basically, data is any set of raw information that can be used, to make a decision. So when it comes to machine learning, a data can be in form of patterns, right? Can be um, in form of predictions. It can be in form of a lot of things depending on what you are working on or what you are building that machine for, right? So data can also be very specific to what you are building. So machine learning relies on data, and like I said before, data is like the foundation for identifying patterns and also making predictions. So based on data that is fed to this machine learning, to these machines, they're able to learn from the data and then make predictions, learn patterns, and also carry out activities that a human would without us being there to, control the machines most of the time. And then we've also heard about algorithms. They're basically mathematical models, right, that process this data and make a decision out of this data, right? So, like I said before, data can be specific to what you're trying to build, same as algorithms. Different algorithms are used for different types of tasks depending on what you are working on. And then we have training. What is training? It's basically teaching the algorithm, right, to make decisions by providing it with labeled data. We'll come to these types of data and types of machine learning very soon. But then basically when you're training, right, in machine learning, it means that you are teaching the algorithm, right, how to make predictions. So the algorithms are written, right, to give like instructions on how on a result you're trying to achieve. And then training involves teaching these algorithms how to make use of the data that you've fed it with to have results as outcomes. And then testing, what is testing? After this training is being done, testing is done to evaluate the performance of the algorithm, right? So after we've trained, for example, if we are training a particular algorithm to perform a mathematical equation, we have to test, right, by giving these, by prompting this algorithm and making sure that it's giving us the correct answers. We can start from answers as little as maybe 2 plus 2, what we already know, or answers, we can start with questions from the data sets we are feeding it to be sure that, okay, this is actually working. And then lastly, predictions. So a model can also make predictions or decisions based on the patterns that it has already learned over time. So I believe that once we keep going, you'll have a clearer understanding of what we are working on today. All right, so we have introduction to machine learning algorithms, like I said earlier, and let's look at the types, right, of machine learning. We have supervised learning. What does this mean? I remember clearly um, engineer Eugene going through this with us on the day of the class. Supervised learning is basically algorithm that is trained on labeled data, right? So what does this mean? What does this, when we say labeled data, what does this mean? It means that the inputs and the outputs are known, right? Inputs and the outputs are known. This can include regression or classification of tasks. For example, we are trying to predict the prices of houses, right? Um, it's labeled, meaning that, okay, at a particular place, maybe, for example, in Sierra Leone, the prices of houses are $50, for example. We are feeding this data, right? Remember that I mentioned learning, that's the training. We are feeding this data. It's called supervised because they are labeled. So for example, on your database, you can have country and then prices, right? Or you can have, yeah, you can have countries and then prices. You can see that there's already some labeling going on there, meaning that you can have countries and then under the prices, you have the list of prices available. So this machine learning is able to detect, right, based on the data that has been fed to it, it's been able to predict an outcome of maybe a house. For example, if in Sierra Leone, you are feeding data to a particular model saying that a house is $15, and I am feeding as well from my end in Sierra Leone saying that, okay, a house is $16. Someone else is feeding from Sierra Leone saying a house is $17. You can see that at the end of the day, if someone wants to use that model to check the prices of houses in Sierra Leone, based on the data we fed it, right, we can see that the result the person will have, right, the algorithm will be able to bring an output to show the person that, okay, the prices of houses in Sierra Leone is between $15 to $17. right? Depending on the type of house, right? So that's why I say depending on the data, you can go as far as feeding it data of 2-bedroom flats for $50, 10-bedroom flats for $100, so that when someone else uses that particular model to want to get information online, they're able to see price ranges, right? Between like accurate price ranges because of data that has been fed it. I hope you understand. But then when we come to unsupervised learning, what does this mean? This is quite the opposite. At this time, the data are without label, right? So now the data has to find their own patterns and structures. Sorry, the algorithm has to find their own pattern and structures in the data, right? Um, These are being used for like lots of examples. As you can see here, the model works with unlabeled data, meaning that it has to find patterns and relationships within the data on its own. Now, for example, we just feed it, okay, Sierra Leone and $50. We've not labeled it to say, okay, country is Sierra Leone and then price is $50. So on its own, it has to figure out which of it is the country and which of it is the price, right? There are various applications that we can see it, including customer purchasing behavior, meaning that today you might feel like buying rice, for example, and tomorrow you don't feel like buying rice. It's not certain. There's no accurate label given to the behavior of a customer, right? Um, then let's look at reinforcement learning, which is also a type. And this type of learning involves an agent that learns by interacting with an environment, making decisions, and receiving feedback in form of rewards or penalties. What does this mean? Example, I know about gaming, right? I know about gaming and also in some forms of robotics as well, right? So in this particular situation, an agent is being involved, so like a middleman, and it's learning from the environment, right? It's learning based on decisions from the environment and then feedbacks as well. So for example, if you, let me just give you like a simple example of feedback. If you go on maybe Google and then you are trying to book a hotel, right? You can be able to see comments there, right? And those comments are simply like feedbacks to say, okay, the customer service in this hotel was really good. From there, the algorithm is learning so that when you search for hotels in Sierra Leone, that particular hotel that the customers have given positive feedback on should appear, should rank at the top, right? So, in other examples, other typical examples, we have it like gaming, because when the algorithm, the agent is able to learn by interacting with the environment, right? And then making a decision based on the learnings that's been able to get from the environment. There can also be feedbacks, and these feedbacks can be in form of rewards or in form of penalties as well. All right. And then you can see that the model will now keep on learning to take action in order to keep on maximizing the rewards it has. This is very, very typical with gaming, like mentioned here. We also have some data processing and feature engineering. So let's quickly look at that. So what is data processing? Right. So before feeding data into a machine learning model, it must be cleaned and transformed. This includes handling missing values, encoding categorical variables, normalizing or standardizing numerical features, and splitting the data set into training and testing sets, right? Proper pre-processing ensures the model can learn effectively from the data. So for example, if we are feeding it the data, right, and then you've given it a particular price of housing in Sierra Leone, and then I come and I'm supposed to feed the data to, and then I just wrote the area in Sierra Leone, but I forgot to add the price. So this data pre-processing, so before the data is being processed, right, this has the name pre-processing. Before it's being processed, this means that I will have to go through the data, right, that we are being feeding, that is being fed to the algorithm, and then fill in the missing parts of the data. Feature engineering is the process of selecting, modifying, or creating new features from the raw data that will improve the performance of the machine learning model, right? So This is basically the creation and modifying of features, right, from data. Because at the end of the day, our goal is to make sure that we are able to feed the model accurate data for it to be able to give us accurate outcomes as well, right? All right, so let's quickly look at this as well. So we have regression and classification models. What is regression? What is classification models? I believe this note will be sent to the group immediately. So let me forward that immediately so that on our own, we can also go through it. But I believe I've also sent it to the group before now. So please do well to check on the group after now. Okay, so regression is used when the target variable is continuous, right? For example, just like I've been saying, we're predicting the price of a house based on its features, like, the size, location, the age, right? So common regression algorithms include linear regression, polynomial regression as well, and decision tree. On your own, you can always, go through each of these types to have better understanding. And then we have classification models. This is when the target variable is categorized, right? Um, what does this mean? For example, in classifying emails as spam and not spam, there are some certain things to look out on in order to classify. For example, as well, if you're trying to classify a house, you can classify a box as a house. I hope we know what classification means. It's more like saying, okay, we have a bag of balls, and then there are green balls, there are red balls as well, and then there are yellow balls. To be able to classify means that you're able to arrange the red balls into one, and you're able to arrange the green balls into one and so on, right? Arrange them together based on the similarities. So you can read more on the evaluation of the model performance, and this was our weekly activity. So just to touch on the model performance, because of the timing. Okay, so we have evaluation metrics. I mentioned evaluation at the beginning, right? Because we use evaluation metrics. We have some common evaluation metrics. R squared is there. MSE, for which stands for mean squared error, is there. F1 score. There are a lot. So on your own, you can definitely go through this. You also have cross evaluation, which includes splitting the data set into multiple folds and then training the model multiple times, each time using different folds as a test set, right? To test, to make sure that you divide the data sets, right, into multiple folds, and then you test them, right? You train, and then you keep training and you keep testing to make sure that the performance, right, is accurate when it comes out. And we have our weekly activity and then our week 2 project as well. So please, let's go through this. Remember that we handled Kaggle the last time, hence the video on the YouTube. I sent the video. So please try your best to go through it. But then before we get done for today, because you need to understand Kaggle to be able to work on this weekly activity and the weekly project as well, right? So with today, we definitely have to meet within the week. We'll discuss the time for meeting in the group within the week. We should meet at least 3 times before the weekend so that I can keep up to speed with whatever issue you're facing, and then I can know how to come in to assist you, even if it means getting on a call with you, right, to try to fix some issues. I'm very, very glad to help you do that. So the project I'll be expecting is the project and activity is just to keep you up to speed. But for the most part, I want your focus to be, okay, okay. So for the most part, please, I hope you can still see my screen. Let me see what you can see. Okay, good. Okay, we can see. All right. So for the most part, I sent this link to the chat. So please click on it, register. If you already registered into Kaggle, because we used it the last time, if you already registered, please sign in. If you're signed in, you can just begin the course. It's a 3-hour course. So I just want you to have more experience with machine learning. And the most important part of this is that I want you to build, right? That was the major part. So we've been treating theory, theory, theory. Now I want you to be able to build, right? So if you look through this, these are the lessons you'll be taking, right? And your instructor is Dan Becker. I've attended a few of his class and I love that. You can also go through some models here, some data sets here as well, and check some codes. There's a lot you can get right from Kaggle, right? So you can check some documentations here as well. You can check for some support as well, for you to have better understanding of what you're doing. So I want you to binge on this site and learn. You can create time and begin this course, right? So you can check for data sets here, if you need access to some of the data sets here. So you can see different data sets based on computer vision, classification, education, computer. There's a lot you can get from here that will be really, really useful to you as we keep learning. Then you can also check for some models as well. You can even go as far as creating your own data set, right? So I'll be checking in with you to see how far you're going. There are different models you can use here. We have Gemma model from Google. We have the Llama model, Llama 3.2 from Meta. There's a lot we have from Brainy Dabs. So on your own, please go through some of these models as well, play around with it, and know what works for you, right? So my major focus for now will be the learn, but now whilst you're learning, you can also keep going through this, right? So we first intro to programming, right? The last class with Kaggle, and now I'll be taking it down into intro to machine learning. So we'll learn how models work, right? We're learning how models work. Okay, yeah. So we'll be learning how models work. We'll be learning basic data exploration. So you can learn how to load and understand data. Even the data you create on your own, you can also be able to learn how to load and understand it as well. And then we'll also be building our first machine learning model. I'll also be working on this as well so that we can also be able to give ourselves feedback. Anywhere you have issues, please do well to reach out as well. All right, so we have less time left, at least about 3 minutes. So let me just quickly go over this. So any questions you have, please reach out to me. We have model validation, and then we'll have to work with machine learning algorithm too. So I like that this is like an all-in-one, right? And then we can also take some competitions, right, to help you track your progress, see how much you've been able to learn so far. And this is just a 3-hour course, and I'll be really happy, I'll be really glad if you can go through this. We'll find time to meet within the week, and if we can't meet every day as proposed within the week, I will also do some recordings, some teachings, and then I will upload them for you to go through it on your own spare time. By the end of the day, I want you to be able to present the certification to me by Wednesday next week. So please go through this. So in the next 3 days, I want to be able to see your badge and your certificate. So this is free. There's no cost, hence why we chose this for you. So please go through this. And if you have any issues, please do well to reach out to me. I'll post this video. I'll upload this video tonight for you immediately after the class, and then I'll share the link as well. So please feel free to go through this. If you have any questions, please feel free to ask. All right, thank God you've been able to see this on the group. So yeah, I've sent the slides to you on the group as well. So please feel free to ask any question. Please feel free to reach out to me. That's why I'm here. Okay. So thank you so much for your time. We have just 1 minute left. I'll send the attendance form as well to you on the group. So please fill in the attendance form ASAP and submit to me today. All right. Thank you so much. And I'll see you in the next class. We'll discuss, okay, when you have time for the next class, and then I'll see you. But I'm always happy to help, so please feel free to always reach out to me if you're confused. But I want you to be able to build a model and then present a certificate to me before Wednesday. Thank you so much, and have a nice evening. Thank you for your time. Bye.